Good morning, good afternoon, good evening, wherever you're hailing from. Welcome to the OpenShift Administrators Office Hours. I am Chris Short, executive producer and host of OpenShift TV. I'm joined by an only all-knowing vert-wise Andrew Sullivan. I call you all-knowing vert-wise, but you're all-knowing in many things. This is why you're really great for this.
So long as it's something I know, then yeah, I know it. Otherwise, I don't.
You know it, and you're all knowing about it.
So
hopefully.
yes, the abominable, not indomitable.
There you go. I like that. All right. So what are we talking about today?
Yeah. So first of all, welcome to the Administrator Office Hours, OpenShift Administrator Office Hour. So for anybody new or for a refresher, this is intended to be an Ask Me Anything style of session. So come with your questions, whether they're about how to install OpenShift, how to use OpenShift. We can certainly entertain developer-centric questions, but outside of, I think, both of our knowledge bases. So that would be, we'll have to get back to you on that. So today,
I'll connect you with the right people, but yeah.
Exactly. So today I wanted to talk about operators. And you may be thinking to yourself, but Andrew, you just said that we're not going to talk about developer things. So operators are core and central to OpenShift, and they were really the driving force behind the version change of OpenShift 3 to OpenShift 4.
Mm-hmm.
And it's critical to understand operators within OpenShift 4. So that's kind of the central topic that you and I will be conversing about. Welcome any questions around that. But for the audience, you don't have to ask us questions just about operators. Ask us questions about whatever you want. We'll certainly
whatever
detract and move away from that. So let me find the right window here. So many tabs.
Huh. 100 tabs at least, I think I'm up to.
I was having my one-on-one with Aubrey earlier this week, and I was commenting on how I feel scatterbrained because I have so many windows, and usually each window is a different thought process, and each window has so many tabs that it's now reached the point of I need to go through and close out some things.
I 100% feel that pain.
All right.
I also need to go through and organize my bookmarks better. I'm having a hard time finding things. I have so much stuff bookmarked that I'm not getting the right auto suggest when I search for something that I know is bookmarked.
Yeah, that can be an issue. I've recently so I use the Brave browser. So they recently re-enabled sync. So I've been using sync across a whole bunch of different devices in order to keep my bookmarks in order, etc. So it's helpful. Sometimes it's not helpful. If I'm looking for something non-work related or something that is a distraction, right, if you will, right? Hey, I want to look at the news and see what's going on in the world because I am feeling too happy or something. So that pops up in my history everywhere that it's synced.
Right. Yes. No. I'm too happy. But
did you know there's a pandemic going on?
I did know.
Yeah.
The problem with me is that I end up using multiple computers and multiple web browsers every day, no matter what. Right. I'll end up opening Firefox and I have something going on over here. I'll have multiple windows of Chrome. I'll have Chrome open over there and Firefox. And then over here on this box, it's Safari. And it's just I just want all this to work together. Right. I'm tired of you're in the Google silo, you're in the Firefox silo, you're in the Apple silo. Right. I just want the stuff to work all together.
Yeah. The Nirvana, if you will. Good luck, by the way.
Yeah, no, I'm actually looking at bookmarking services again, like it's the early 2000s. Yeah.
So I'm going to do something that I haven't done on this channel before, and that's going to be use slides. And not
Wait.
just use any slides. I'm going to put them into presentation mode even.
You've never used slides on the show?
I don't think so.
I don't think. Well, that,
On this one. I think I've
yeah,
used them
no.
on one or two others.
Yeah, on different shows. Yeah.
Yeah. So again, this is the focus of the topic today. This is, I think, about 20 minutes worth of slides, give or take.
Mhm.
I don't want to use slides. This is just the easiest way to tell the story. And then we can dig around and we can explore some things. And I may even do that in the middle of talking to the slides.
Awesome.
So yeah, hold on. But anyways, for anybody watching, again, don't be afraid to stop, ask questions. I don't mind taking a break to answer questions not related to what is coming out of my mouth, if you will.
And yes, sometimes I can even answer questions about things coming out of Andrew's mouth.
Not just sometimes, many times.
That just doesn't sound right.
Sometimes I don't even know it.
Anyways.
All right. So let's talk about operators. So the first thing for anybody who has sat in a sales meeting, right, who has had a meeting with their account team, talked about OpenShift 4, you've probably seen a slide like this one, where we do a lot of hand waving, right? We talk breathlessly about how great operators are and all of the problems that they solve and how they're the best thing since sliced bread. You may have even seen a slide like this one, similar type of concept, right? Giving you the ability to, I like the sentence down here at the bottom. That's one that we use pretty frequently of codifying operational knowledge and workflows, and then putting that directly into the cluster itself. But what we don't do a great job of all the time is translating that into, but what does that exactly mean? Right? If you take a step down and you talk to, a more technical person, oftentimes it'll be, things like, oh, well, we use operators for all of the OpenShift components, and, the operators operate the cluster and you don't have to worry about. Like, great, but what does that actually mean? So let's start with, how does that actually happen? And what does that actually look like? And I want to take the context here of, let's think of, as an operations person, as an administrator, what happens with an application. And I'm not talking about deploying the application, right? I used to do Josh Atwell and I used to do a presentation that would talk about the hand grenade of deployment, right? Where the applications team would package up their code into this little hand grenade shaped object and then lob it over the wall to the ops team and say, good luck.
May the force be with you. Yeah.
And kind of, so that's where I want to start with, is we just caught that grenade or whatever it happens to look like. And where do we go from here? So let's start with the application itself. Doesn't really matter what the application is. Doesn't matter what it's written in. Doesn't matter how many components there are. Doesn't matter. Right? All we care about is we have an application.
This thing needs to run.
Exactly. And outside of Kubernetes, right, traditional workloads, and let's face it, even though we Red Hat love to talk about containers and Kubernetes and OpenShift and all of that, the vast majority of workloads today are not in containers yet.
Correct.
So I have an application. Hey, operations team, let's put this into production. So this means that I need to do a bunch of things, right? First and foremost, maybe it's packaging it up, right? I got to put it into an RPM. And then I need to figure out where I'm going to deploy it to, right? Create a help desk ticket. I need 17 virtual machines that have these characteristics and these operating systems. Then I have to go through and deploy the application, right? Connect in, maybe I use Ansible or something like that. Deploy the RPM, put in a bunch of configuration data, all of those files on the file system. Configuring, you see the list here, firewall ports, starting services, right? All of these things that go into getting it up and running. And you've probably heard this story
and
before.
There's not even like, and then you get into the maintaining of it, and then there's even more. Yeah. So
exactly. Right. And that's the next step, right? Hey, I just updated the application, or the apps team just updated the application. Now what?
Yeah.
Right. How do I go through and do this? Well, we ops guys, we solved this a while ago, right? Automation.
Yeah.
I mentioned Ansible, right? How many of us actually go through and manually deploy applications more than the first or second time, right? There's a huge number of tools out there to take care of this for us and make it as easy and simple as possible.
Yeah.
So welcome to 2012. We have now automated the deployment and the lifecycle of an application. So let's talk about this in the context of Kubernetes. So with Kubernetes, now I take that application and I'm, well, putting it into a container.
Mm-hmm.
Right. And that could be as simple as, and again, you've probably heard this story for the last 5 to 7 years, depending on how long you've been in contact with containers.
Mm-hmm.
Right now, I take my RPM and I install it to a container. I take all of that config and I put it in the container. Maybe I expose it through environment variables or whatever it is.
Right.
And then the Kubernetes part of that is just translating that into Kubernetes objects. Hey, I deploy my container using a deployment. So that way I can scale it up and down. I pass configuration into the application using a config map or a secret. I expose it using services and routes, so on and so forth. So just like before, we want to automate this because, well, we have the same problems. We have the same life cycle that we have to deal with. How do I, when the next version is released, how do I update that? So oftentimes this is, scale down to 0, change the deployment, whatever that happens to be, and then bring everything back up.
Right.
And we've got a lot of automation to do that as well. Sometimes it's the same tools, right? Ansible, et cetera. So if we have automation to manage our application lifecycle inside of Kubernetes, there's nothing that says that we can't containerize that application, or excuse me, that automation. Right. I can put an Ansible playbook into a container, and I can deploy that container right back into Kubernetes if I so choose. You misspell operators there.
I did. Sorry. Anyways, go ahead.
So I can take my automation and I can deploy it into Kubernetes right alongside the application code itself. So how do I trigger that automation as the administrator, as the user? And this is where we begin to get into some new territory.
Mm-hmm.
So from a Kubernetes perspective, there's 2 things that we want to be aware of. One is a custom resource definition. And this simply tells Kubernetes, hey, here's this thing, right? Maybe it's a MySQL database, and a MySQL database has these characteristics. And the other one is an endpoint or something inside of the cluster that is going to take action as a result of that. So if that endpoint, that thing behind the scenes, that automation is the controller, and I have my CRD, I can link these 2 together so that as the user, as the administrator, I interact with those via a custom resource instance. I create a new MySQL. Kubernetes informs the controller, hey, something happened. Controller, do your automation. And maybe that automation is, okay, well, I need a new instance of MySQL. Let's create a new deployment. Let's request some new PVCs, so on and so forth. Or, hey, the version was updated. I need to do these actions. It's literally just executing that automation that we would have created as the administrator. So this is just the text version, or the slide version of what I just said here. So the important part here is over here on the kind of right-hand side of the slide I have that operator. I have that automation that's running inside of my cluster that interacts with and executes things or translates them into those Kubernetes native resources. When I create a new instance, it creates the deployment or the stateful set or whatever that happens to be, and all of the resources that go along with it. So the goal here, if you've heard of this, right, and congratulations, by the way, you just created an operator. So the goal here is democratizing access to applications. When we think about, particularly in the context of a database, right, how many of us know or we have a curmudgeon-y DBA inside of our organization?
Why'd you have to pick on DBAs?
Because I was one.
Oh, okay, fair enough.
Where do you think I get my
You are the cuddliest curmudgeon I've ever met. Yes.
See, so if we have a DBA, and yes, they are sometimes difficult to work with, but that's because they are biased. I know when I deploy a DBA or a DB instance for this application, I need to do these things to make it work as good as possible. I know with my infrastructure, I need to do these things because the storage has these capabilities and compute this and network this, etc. So we can embed that directly into the automation. They probably already have automation that does that. So congratulations. we now have an operator. And through that operator and through those custom resource definitions, anybody can access that knowledge. So now we can rinse and repeat, right? We can create an entire catalog of operators. We can increase the capabilities of those operators. So maybe it's going from just basic install and upgrades to the deep insights level here, right? This comes from the operator framework website, by the way. And it's expanding what that automation is capable of doing. Is that automation looking at the metric service to collect metrics and be able to make decisions on your behalf for preemptive or proactive operations, et cetera. Right? We can repeat. We repeat and add more applications, more application components into this operator paradigm. So that maybe my application is a 3-tier, a 5-tier, or a microservices with 400 different components. I can now manage each one of these
GIF, by the
all
way.
the same. I know. Thank you, Jafar.
Yes.
So the problem now happens, or has now been changed, so that we have the same lifecycle management paradigm shift associated with the operator that we did with the application before. Hey, I increased the capability of my operator. I added this new ability. How do I now replace the existing automation? Remember, it's just a pod. So maybe it's, replacing the deployment or modifying the deployment to replace the pod, et cetera. So it's really important to, lifecycle manage those. And this is where OLM, Operator Lifecycle Manager, comes in. That's exactly its role. I define, using a cluster service version or CSV, hey, this operator needs these resources. It defines these custom resource definitions. It needs these permissions for the service accounts, right? These role bindings, et cetera, as well as has these other dependencies. And then we rely on OLM to go through and make that a reality. So OLM offers that catalog of, here's all the operators that are available. Please deploy this operator,
right?
And making sure that everything it needs is there. It does a bunch of other things. I'm not going to go into details here because I could spend a while about this. This slide was actually presented by it's either Daniel or Rob during one of the community operator framework updates. So if you want to hear them talk about this, that would be the best place.
Yeah. An operator framework is a CNCF project. It was just donated a few months ago. So it's agnostic as far as Kubernetes go. It is not just an OpenShift thing. So yeah, we donated to CNCF. I can't remember if it's incubating or sandbox at this point. But yeah, it's been in the CNCF ecosystem for a couple months now, a few months.
And to be clear, you don't need Operator Lifecycle Manager to have operators.
Correct.
So let's talk about this in the context of OpenShift, and in particular, the core of OpenShift. So when we think about OpenShift, and if you're familiar with the install process, literally the first thing that happens after, of course, installing CoreOS is a Kubernetes cluster gets stood up. And then we deploy Operator Lifecycle Manager, and then we start installing a whole bunch of components, right? The console, the registry, the routers, and on and on and on and on. So when you think about it, OpenShift is operators. All we've done is all we've done is take vanilla Kubernetes and all of the things that you need with Kubernetes to have a production deployment. And we've done the automation for you of deploying and managing and lifecycling and configuring all of those different assets, all of those different components. And we do that, right? OpenShift itself is controlled through the cluster version operator.
Yes.
So literally, OpenShift is Kubernetes with OLM, and then a series of operators that are deployed and managed by the cluster version operator.
So for folks that are listening that don't know what OLM is, it's Operator Lifecycle Manager. Think of it as like a cataloging and management tool for all the operators in your life, right?
Yes.
Yeah.
Thank you.
No problem.
And just as further proof of that, you can see this was taken a couple of weeks ago before 4.6 was generally available. So all I did here, this is just after the install finished, I did an OC get cluster operator.
Nice.
And these are all of the out of the box operators that are deployed. And you can go in and you can look at each one of these, which we'll do in just a moment.
Yeah. Notice,
So that's
right?
operators.
Like we're not leaving much to chance here, right? Like the node tuning operator will respond to events constantly, right? Like if there's an event that it needs to reconcile, it will do so. Same with networking, same with storage, same with the whole 9 yards, right? Like etcd being installed with and maintained with an operator really allows us to not necessarily worry about how etcd is configured when we're building up OpenShift clusters, right? Like we know that it's done in a way that works.
So that's my background on operators, right? Of this is how we do the logical progression of, think about OpenShift 3. If you're familiar with OpenShift 3, how do we deploy OpenShift 3? Somebody went and stood up a bunch of rel nodes. They then used Ansible to go to each one of those nodes and deploy and configure a bunch of components. OpenShift 4 is kind of the same, right? I stand up a bunch of CoreOS nodes. I deploy Kubernetes. I deploy OpenShift on top of it. It's just those last two things all happen via operator.
Right.
So all of that Ansible automation that we used to use is now operator automation. So to use one of my favorite terms, right? So where'd my cheese go? So if we understand are you not familiar with the Who Moved My Cheese?
Who moved my cheese? No.
Yeah, you should look that up, right?
Okay.
So it's a management philosophy or an evolution thing of, if I am, and it's usually applied to IT workers, of my life is in a steady state and then something changed, right? Somebody moved my cheese. It's in a different place in the maze. So my world has been changed, and you can either, stay where you are and complain about my cheese having moved, or you can go and find where the cheese has moved to. Right?
I like this premise.
But so, yes, where has my cheese moved to? So you'll note that this means that some things are different. Right? With OpenShift 3, it was all Ansible, it was all rel. I could SSH into the node, I could go and dig through playbooks, and I could see exactly what was going on. Right? It was several, billion or so configuration files scattered across a bunch of different machines that I needed to configure. Right?
Yeah.
So
I don't know if it was a billion configuration files, but it was close.
My middle name is Hyperbole. Okay. So what does this mean for us as administrators? So if we grok, right, if we accept that operators are automation, I've simply replaced the Ansible playbooks with an operator. How do I actually administer my cluster? And this is where things are both better and slightly more confusing. So I say they're slightly more confusing because, well, they're not different projects, different components sometimes do things slightly differently. And you can see that. So here I'll pick on one of these. So let's do OC get cluster operator.
Today I learned that you could just do CO and it worked.
Yeah. OC get CO. So you'll see that some of these have two different namespaces. So let's pick on let's pick on machine API. So OC get project.
You picked a hard one to pick on.
No,
or maybe not. Depends how you look at it.
Some of these, and what I'm trying to show here, right here, Kube scheduler. So some of these have an operator namespace and then an application namespace. So here's another one: Kube API server operator namespace, Kube API server application namespace. Some of them are joined. So if we find the registry, so the registry is in one. And if I were to do an OC get pod, we can see that both the operator as well as the registry instance are in that same namespace. So you can see there's a little bit of uneven standardization, which is a hilarious, oxymoron. So that's one thing to be aware of, is we sometimes need to understand how things are laid out. So let's look at a couple of ways that we can cheat. So first and foremost, of course, is simply OC get cluster operator, right? I can see each one of these and I can get details about each one. So I can say OC details CO slash, well, let's look at the registry. Sorry, OC get CO dash O YAML. I think there is a describe. I'm using the wrong terms here. It should be OC describe, just to prove that. Still can't type. There we go. OC describe. Use the right verb. So we can look at the details, either output as YAML or by doing a describe of a particular cluster operator, and it'll tell us high level status. So we can see here the most recent status message, the registry is available, reason is ready, status is true. Down here, right, we're progressing, right? It says reason ready, and then status is false, meaning it's not currently ready, so on and so forth. If there's errors, oftentimes they'll get surfaced up in through here. But remember, this is related to the operator, not the operand, not the application that's actually being operated on.
Right. And that's a good distinction, right? The operator is the thing that puts the operand in place.
Exactly. So underneath this related objects, you can see some additional information. For example, underneath the resources, I can see which namespace is actually affected, right? Is relevant for this particular operator. So, okay, my image registry isn't functioning. So how do I figure out what's going on there? What do I need to do in order to figure it out? So I can do a describe on the cluster operator here. I can look and find out where it's being hosted at. So I can do an OC project. And I can see the pods that are running inside of here. If any of them had errors, right, I could do a standard OC logs or OC describe of the pod to get what's going on. Now, where it gets a little confusing is, because so far I've done nothing that isn't standard Kubernetes.
Right.
Is most of the time an operator, or excuse me, the operand is configured by the custom resource instance. So what do I mean by that? The operator is the automation. The operand is the instance of the application that the automation is enacting on or is doing something against. So that means that, right, if the automation is configuring it, is controlling it, how do I tell the automation what configuration it needs to apply? This is another area where it's sometimes unevenly applied. Right? Sometimes we'll have operators that everything in the configuration is applied through the custom resource, and sometimes it's done through config maps, and sometimes it's done through secrets, and sometimes it's done through, right? There's a lot of different ways that can be done. How do I find out? How do I know? Well, there's a little secret that you can do. If I do OC ADM release info -- commits.
Whoa, right? This one's new to me.
So what this is going to do is it's going to give me the information about the particular release, the particular version that I'm running. And then this commits is going to tell me which GitHub repo it comes from.
Oh, cool.
So
that's super handy, because then you could go read the, I like the commits flag.
Right? So here's this, right? Here's my cluster registry, image registry operator. So I can see that it comes from this particular GitHub repo. And many, many, many times you will find that the engineers have a lot of troubleshooting and other information inside of here. Right here. Here's how to go through and configure all of the different aspects. So even though the docs have some of this information for configuration, they don't always have all of the information. And especially if you're troubleshooting,
not every option is listed in the docs, right? Like,
exactly.
Yeah.
So especially if you're troubleshooting, there's usually not a lot of information in the documentation, and it's super easy to come over to here and check those out.
I need to write that down in my one-liners file here for OpenShift stuff.
So yeah, OC ADM release info dash dash commits. It'll tell you exactly which GitHub repo it comes from, as well as if you really want to track it down, which commit was the one that became a part of the release or was the last one before the release.
Nice.
So that's kind of a crash course. Okay. So the other thing that we can do is, so I can do an OC get CRDs, and it's going to print off this huge list of custom resource definitions. So how do I know, or what do I need to do in order to configure each one of these? And that's where we have the OC explain command. So if I do OC get CRDs and grep for registry, we see that we have an image registry config. And I hope that this works because I haven't actually tested this one. OC explain, and then I do that particular custom resource object. Nope. There we go. So what this does, and we can see here, config provides information to configure the operator. So what this does is it provides me a list, and I can walk through this. So .spec. Right. It has a list of all of the different objects, all of the different configurations that I can do inside of here.
Nice.
So this is one way that we can, from the CLI, right, go through and figure out what precisely I can and what are valid values for my particular configuration. So do an OC get my config for image registry. You can see there's the cluster one. So cluster-o YAML. So inside of here, we'll scroll up just a little bit. We can see underneath my spec, I now have a bunch of information in here. So down here is where I configured my particular instance. So we can see right now, my registry isn't deployed. If it were deployed, it would be using this storage information. It's using a local instance. So all of that is through the CLI. So what about the GUI? So the GUI, we can see a lot of very similar information. If we come down here underneath, come on, scroll down.
You can scroll.
Underneath administration, and then we have a couple of different areas. So one, we have under cluster settings, cluster operators, right? This is effectively the GUI equivalent of doing OC get cluster operator or OC get CO. So I can come here to image registry, and the helpful part is it tells me about the related objects. So we can see here, oh, I have this, let's see, config, right? So I can look at my cluster config, and I can look at the YAML and get the exact same thing. So if I scroll down here underneath my spec, you can see here, management state, right, is right there. So there's my storage configuration.
Nice.
So two different ways of going about the exact same thing. One is through the GUI, one happens to be through the CLI. Which one you prefer, which one you like better, it's entirely up to you. I tend to switch back and forth, much like I sometimes say, kubectl or kubectl or kubectl, or I'm an equal opportunity.
Are you like me and intentionally say it differently every time?
Nobody knows which one they like. So, or let me rephrase that. Everybody likes something different. So I'm trying to include everyone or offend everyone, depending on your perspective.
You're an equal opportunity offender.
There you go. So the other way we can look at these is by going to the custom resource definitions. And from here, we would be able to do like, as soon as I can type,
as soon as you type,
we do the same thing, right? So we have this group. So I just search for registry and see the config. So this one is slightly less useful for the cluster operators.
Right.
So with the cluster operators, right, I have that, that really helpful related objects. So I can see all of the things related to it. Whereas if I come down here to the custom resource definitions, I have to do a little bit of reverse engineering myself.
Yeah, some digging. Yeah. But no, I do like the fact that we put in the cluster operators tab, because that just makes my life a little bit easier when I'm trying to troubleshoot things that I just spun up and a container is not running for some reason, or a node is out of resources because I'm running too much crap, right? Like, yeah.
So let's break something.
Okay, break it.
So I'm going to come in here and I'm going to go to this guy and I'm going to break this. Okay, great. So let's assume that I have, I know. So let's assume that I am attempting to configure my registry for storage and I bungled it, right? I just didn't configure it correctly. So how do I determine that there's an error? So the first thing that we can do, and I'll start with the CLI over here, is do an OC get CO. And if we look at our image registry, so we can see a couple of things here. So let's scroll up so we can actually see the heading here. So one, because I changed the configuration, this column for progressing is currently set to true. That means it's in the progress of changing, right? It is not currently degraded. Usually that is, each one of the operators has a different set of conditions for degraded. I don't know precisely what those are. That would be an interesting side project to figure out.
Oh, to correspond all the statuses to.
Yep.
Yeah.
And the available is also can be confusing. For example, if it is unconfigured, so for example, if I put my image registry into an unmanaged state, then according to its configuration, it is available the way that it is supposed to be, even though the registry isn't deployed and therefore isn't available. I hope that chain of thoughts made sense.
It did, to me at least. If it doesn't to y'all, let me know.
So yeah, so essentially you have to have a little bit of context awareness around what this is reporting. So let's look at our describe CO image registry. So we can see a couple of things here. So one, notice I changed my registry config, and now it's saying that there's an error, right? Unable to apply resources, unable to sync storage configuration. Hey, I just figured out that I fat fingered my, something inside of my storage config. I need to go and modify that. Okay, let's assume that this was not helpful. Maybe it's just saying something's broke. Good luck, right? Go look elsewhere, right? Your princess is in another castle. Okay, so where else can I look? So remember that an operator is automation. So is my operator having difficulty, or is the thing it is operating on, the operand, having difficulty? So if I'm still in the OpenShift image registry project, so let's say that it was the operator. I can't instantiate something for some reason. So I can look at my operator pod, and it's just like any other pod. So OC logs. And I can look at the logs for this particular guy. Now, in this instance, it's surfacing up really good information. Not all of the operators are quite as well behaved as this one of surfacing up, hey, unable to sync storage configuration. So if I have, for example, an image, or if this is failing to deploy, or if this is failing to deploy, something like that, right? I can look in the operator to see what that error might potentially be.
Right.
Okay, let's say, and we can see in this instance, it did successfully deploy the image registry pod, right? So the pod is up and running. So why isn't my application available? Why isn't my registry available? Well, same thing. Just like any other containerized application, we can look at the logs. And what I would expect here, really? There must be 2 containers in there or something. Oh, OC logs.
Resource type, yeah.
Helps if I know what I'm doing, right?
I always, dude, like, I cannot tell you how many times I OC get logs in a day because I just think, right? Oh, I need to pull the logs, OC get, right? Like, but no, it's just logs.
Can you alias that? Can
I wish we could, like, I might just submit that as a PR and see what happens.
So by doing an OC logs or kubectl logs against the specific pod, right, I now get the registry specific log and error messages. And we can now really dig into what's happening inside of there and why it may not be working out.
Oh, I'm sure it's just
bad
spewing complaints. Yeah.
Yeah. So let's flip over to the GUI, right? Same sort of thing. How do I figure out what's going on with my project, with my thing? So the first thing that we can do is we can look at our operator here and we can see that why isn't it done updating? What's going on here, right? So this is helpful. So I can look at my image registry, and right here in the GUI, it tells me. Right? So remember when we did the OC describe CO, this is effectively the same output, just in graphical form. And you can see it's spitting out the exact same messages that we were seeing over there.
And connection refuse is actually quite helpful because it clearly indicates that you're bouncing off something that's not receiving data.
Yep. So, and then if I scroll down here to the conditions, we can see the same thing, right? So it is currently in an error with a progressing status of unable to sync storage configuration. So same as up above. Like before, if I go to my related objects here, I can check out all the different things that are in here. So maybe I want to go to the namespace. And now that I'm in my namespace, I can go to workloads and pods, and I can see all of my pods that are running inside of here, just like before. So here's my registry operator pod. I can click here and go to logs, and we can see that it is very unhappy with me at the moment. And scrolling a lot of lines by. So again, another way to look at the logs that are going on inside of there. Same thing is true of the other pods. I'm not going to reiterate or redo that for that particular pod because it's the exact same process. So, okay, now let me change my configuration. Let me fix my configuration. So
that'll fix you.
Yeah. I'll show you related objects. Go back to my config, go to my YAML, scroll down here and put our correct port back. I could just as easily do an OC edit here, right? Standard configuration modification stuff. And now if we go back to our cluster operator and we go to the registry, we can see it's already updated.
Wow.
Right? Didn't take it long. And it's already up and available and ready to go. I could review all the logs and see all the changes that it took effect, but effectively it's just remembering that even though it's an operator, at the end of the day, everything's still a pod. So you're kind of checking two different places. One is the operator itself. The other one is the operand, is the application that the operator is trying to deploy.
Interesting. So Vedran, sorry if I mispronounced your name over on YouTube, is talking about how he's always trying to explain to developers how to use SCCs. Do we have any resources that we could maybe give Vedran and help him out there, or help them out there? Sorry if I misgendered you.
Let's see.
I'm trying to think. SCCs for dummies. Is there?
So
a book about
yeah,
that?
I know. Outside of the documentation, I don't know. I don't know if Christian's paying attention. I'm guessing because he hasn't been responding. He's not. So Christian is usually my go-to for the security side of things, and determining the security context constraints, which is SCC, that are important and relevant. It is not one of my areas of strengths. So let's see what we can dig up here.
Yeah, I'm digging up some stuff. Let's see. Oh, there's actually a blog post from this year about it, how to manage them, and kind of explains them and so forth, so on. So let me toss that in here. That could be helpful. Check that out, Vedran, and maybe that'll help. Like, give this to your developers in the sense of like, you need to understand how these work, because if you don't, your application won't run.
Yeah, it's communicating what the user in the pod is able to do or not able to do.
Right.
That's about the extent of my knowledge. We can also dig around. So I'll take an action item to dig around inside of or with our security PM and folks and see what we can find. So if you will please send me a message. So either Twitter, Practical Andrew, or email andrew.sullivan No, Siri, I don't want you to send a message.
Weird.
Yeah, I don't know where that came from.
Yeah. Okay.
So please send me a message.
Yeah, and we can get you hooked up.
Making sure that she didn't start talking again.
Anyways, not talking now. Anyways.
So yeah, send me a message just to connect, and that way I will reply back with any resources that we find to help you with that inside of your organization. So happy to do that, and then maybe we can use that as a topic for 2 weeks. So do note next week is a holiday here in the U.S., Thanksgiving.
Yes.
So neither Chris or I will be available.
I am taking some much needed time off. Yes.
Yep. So we will be back for this show in 2 weeks.
2 weeks. Yeah.
So
cool.
Doing anything exciting for Thanksgiving, Chris?
Well, the state just went into full lockdown mode, so no.
Yeah. Well, I don't know if North Carolina will do that or not. I feel like we probably should because things are a little crazy. Meanwhile, my wife is still talking about wanting to deep fry a 14-pound turkey, even though there is only 5 of us and not the usual 12 plus.
That is going to be an enormous amount of turkey per person.
I think I've got her talked out of it. We're just going to roast a chicken, normal sized, not Costco sized chicken.
Right. Yeah. What was it? I think it was Whole Foods. They had for a little bit a gimmick about like Thanksgiving guarantee or whatever. Like even if you burnt your turkey somehow, they would give you like a gift card or something. It was like the first 1,000 people that showed up or whatever. But it's like, why not do that for everybody if you're going to do it? You are owned by Amazon.
All right. So that's my crash course on operators.
That's awesome. I would like to remind folks, you can write operators in Ansible, right? So if your application has needs that are like external to a cluster, right? Like I need to flip a load balancer or change some port or something, DNS, whatever. You can do that with Ansible too. And you can use a Helm chart as well as writing it in pure Go. And there are some other tools for writing. There's Kopf, K-O-P-F, for writing operators in Python. There's Flant for writing operators in Bash. I mean, there's the operator framework, which allows you to do a number of operators just by itself. So there's plenty of ways to write an operator, no matter what your skill set is, I feel like.
I'll pick on one. So this is OpenShift virtualization. So this particular component, the SSP operator, is an Ansible operator.
Nice. That's awesome.
We go in the logs here, right? You can see all of the Ansible log output that's happening inside of here.
Oh, wow. Yeah. Cool. That's awesome. That's actually really, really cool and good to know. Always seeing when we're using Ansible operators inside OpenShift.
So, and then other components are written in Go and etc. But that one I happen to know is in Ansible.
Awesome. How about Java? I think there is something out there for Java folks. I would have to look it up. Hang on.
Yeah. So let's look at or take a step back. So if we go to github.com/operator framework. So if you look at the operator framework, which is the CNCF, right? Sandbox. Is it Sandbox or is it?
I forget.
So it's the CNCF project.
Yeah.
So the operator framework is made up of multiple things. So first is OLM, right, itself. So for managing, controlling, interacting with operators, not necessary to deploy and use an operator. It is for managing operators themselves.
Incubating projects. Sorry.
Thank you. So the second one is the operator SDK. So the operator SDK is an easy way of getting started writing your own operator. It's essentially scaffolding and a bunch of things to help with that. It is not the only way to do it. And I think that that's really important to point out, because if you look at the operator SDK, it really focuses on Go, on Ansible, and on Helm. Obviously, those are not the only 3 things that are used, right? I think I saw the other day that Python is now the number 2 most popular language, right behind Java.
Yep.
So I would be willing to bet that the community has ways of creating operators using those languages as well. The other thing I'll highlight here is we go to operatorframework.io.
Mm.
So they have a whole website here that has a tremendous amount of information. So the framework itself, remember, is really focused on developers, on creating operators themselves. But if I go up here to documentation and OLM documentation, Operator Lifecycle Manager, this is the component that's responsible for, right? OLM is responsible for like this operator hub display. It's the one that's collecting all of those catalogs. It's displaying them back, or it's used to display them back here, right? It's the part that's deploying those operators. So it can be helpful to have access to all of the information relating to OLM when you're trying to troubleshoot or when you're trying to learn more about how OpenShift works down at that core level. So tons and tons and tons of information inside of here about how it works, about things to look at. You see this troubleshooting, right? I have this catalog source. How do I troubleshoot catalog sources? Particularly for customers who are doing restricted network or offline deployments, right? In our documentation, we say, OC, ADM, mirror, blah, 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 blah. And then to get the deployment images across. And then we have a separate set of tasks for mirroring all of the operators. So if you want to dig into details about what's actually happening there, if you have issues, it's another great place to look inside of there.
Mm-hmm.
So with that, I'm out of words.
Cool. I would encourage you to check out operatorhub.io. There's a lot of operators there, and they are open source as well. So if you're like, hey, I want to deploy a DB, well, guess what? Percona has an operator, and Mongo has an operator, and all these people have operators to deploy various databases. You can find them there. You can also, it's a lot like, like copy pasta. You can kind of build your own operator to do whatever you want and change some things here and there based off another person's operator, right? Like,
yeah. I think I may have mentioned it before. I don't remember if it was on the admin hour stream or on a different one. So if you go to operatorhub.io, so this is the upstream community operators. Essentially, anybody can create an operator and submit it to be included here.
Yep.
And more precisely, if you go to github.com/operator framework and you browse to this community operators repo, that is where all of these are at, specifically in the upstream community operators subdirectory.
Yep.
So all of the operators here, all of the code, everything that is behind what you see on this web page exists inside of this particular tree. However, there are two other types of operators. So if we look at Operator Hub inside of OpenShift, it's going to be different. You'll notice there's 372 here, whereas if we look over here, there's 166. Right? Yeah. Why is there such a discrepancy? So upstream community operators, anybody can create, anybody can submit, right? Once the PR is approved, congratulations, you're listed in Operator Hub. So when we look in Operator Hub and OpenShift, we have community operators and we have a bunch of others. So community operators with this fancy community tag are the ones that are found. So I'm back in my operator framework /community operators GitHub repo. They're the ones found in this community operators subdirectory. So the difference here is that somebody at Red Hat has basically tested and validated that this operator will deploy into OpenShift. So simple things like it's not going to run using a root user, right? So back to SEC. And that's basically all of the validation that has been done. So that's why we have uneven or different sets that are listed there. So the third type of operator that you'll see is the certified operators.
Nice.
So these are not found in the operator framework GitHub repo. They're on registry.redhat.com. And these are ones that have gone through a full certification suite. If you're really curious, you can actually see all of that. If we look here in Certified Operator Build Guide, and I'll post this link in here. So if you're curious about what that looks like and how to go through, and if you just want to know what the certification process looks like and what our partners go through to do that, that's a great resource to see all of that information.
Absolutely.
So, and then the last type of operator that you'll see inside of here is the recently announced marketplace.
Yes.
So
the Red
these
Hat
are all
Marketplace is there for your consumption.
I shouldn't say the last type because the other type is the Red Hat ones, and these are the features of OpenShift itself.
Mm.
So if I wanted to deploy cluster logging, it would be a Red Hat operator.
Yeah. This is great. This has been awesome. I feel like we've covered operators very well. Again, if you have questions, feel free to reach out. Practical Andrew on Twitter, Chris Short on Twitter, C Short at Red Hat is my email. I forget your email. Is it just A Sullivan or
Andrew.Sullivan?
Andrew.Sullivan. There you go. Yeah, feel free to reach out if you have questions about operators. We can get you in touch with the experts if we can't answer it ourselves. And yeah, anything else, Andrew?
I do see a question from Murat. Operators and databases, any production hints?
Ooh, don't write it yourself. Use someone else's.
So in all seriousness, it depends on who the vendor is and whether or not you trust them. So if you're using a third party, right? So here I'll pick on, come on. So let's get rid of this guy and then
Database.
Crunchy.
Oh, there you go.
So, the Crunchy folks have, their operator for deploying Crunchy DB into, or Crunchy Postgres into OpenShift. If they're your vendor, if you trust them and you want to use that, absolutely, by all means. I always recommend working with the partners to understand precisely what their operator does and doesn't do, because it can be different, right? You see here, their capability level goes all the way up to autopilot. But autopilot might mean something different to you than it does to them. So again, working with that partner to understand precisely how far it goes and how to integrate. MongoDB is going to be the same way. CockroachDB is going to be the same way. CouchDB is going to be the same way, so on and so forth. Oh. You can also augment those capabilities, right? You can effectively create automation that also looks at and does things based off of what's going on inside of one of those databases if you so choose. So, like always, just have a full understanding of what's going on, right? Feel comfortable with what is and isn't happening inside of the cluster and in the application, kind of standard stuff.
Awesome. All right. Well, I've got another live stream to jump to, Andrew. So
I would be disappointed if you didn't.
Any parting shots before we go?
No, just a reminder that 2 weeks we will be back. Next week is a holiday. So for those of you in the United States, not North America, because it's Canada
Canada's already done theirs. Yeah.
Yep. Theirs was a month or so ago. So for those of us in the US, happy Thanksgiving. I hope that it is relaxing, and hopefully you can see your family, even if it is remotely. For the rest of the world, we will see you in 2 weeks, and continue to be safe.
Yes, stay safe out there, folks. Thank you.
Govind Rangasamy here from Apranix, and I just need to pull this up here. Oh my goodness. And today Govind's going to be talking about effective container application resilience. So welcome, Govind. How are you today?
Hello, Michael. Thank you for inviting. I'm doing great. Thanks for this platform to Red Hat and as well as IBM get to be in. You know, we have been a partner of Red Hat for a long time, and it's great to be with you guys.
And you know, we've been kind of prepping for this for the last hour here, and we're both here in Massachusetts. We have changing light conditions. We've got, you know, sun coming in and out of the clouds. I didn't realize that you're down in Holliston, right?
Yes, I am right where nearby the Hopkinton, where the Boston Marathon starts. You know, I don't know how many of the folks listening to this know this. You know, Boston Marathon starts right from our location and it runs up to Boston. So it's a, you know, it's this year we missed it, but that's a location I'm in.
Well, this year certainly has been challenging to say the least. But you've been around a long time. You've had a pretty successful career, right? You were at Fog Panel, Actifio, Eucalyptus, a lot of big names. Pretty successful career so far.
Humble enough, you know. Thank you for other companies for giving me the opportunity to run along those wonderful time frame. And I've met tremendous people along this journey. You know, we have to give it to the team to make other people successful. So, you know, similar to other platforms and other teams, you know, we have gotten a great team with Apranix as well. So fortunately there.
And you folks are about, what, 4 years into it now?
Yeah, we have been at this for 4 years, you know, when it takes time to change the market. So yeah, about 4 years now.
Okay, well, tell me about it. I mean, you're the CEO and the founder, so you started this company, and I think you were CEO of a lot of other successful companies. So hopefully, you know, you'll have the same good luck here. But why Apranix? What's in the name? When I think, you know, Apranix, it doesn't make me say, oh yeah, I know what that is. Like, why'd you pick that name?
Great question. So, you know, Apranix starts with something to do with applications, right? We always had the thought. Now, I come from the storage background and cloud infrastructure background. Like as I mentioned, Eucalyptus was private cloud as a service, compatible with Amazon Web Services back in the day when, you know, nobody understood cloud as such. And then we, as a team, started with a multi-cloud management before all these, in a market talking about multi-cloud. So we had this multi-cloud management to layer on top of the typical infrastructure, you know, be it on AWS, obviously on Eucalyptus or Azure, and then OpenStack, all right? And then when we looked at all of that, you know, everyone was worried about, okay, so I'm going to port this virtual machine over from one cloud infrastructure to another, or VMware to AWS. Those aspects started back in like 2011 and 2012. But what really mattered is that, you know, if you don't have the applications properly running on these platforms, I mean, these are like, initially these are all hypervisors and, you know, start porting the applications over and workloads will start. But when you think about applications as such, they were going to become a much more distributed on the software-defined infrastructures, right? Kubernetes wasn't there at all. I mean, Kubernetes started back in 2014. So we started working with Kubernetes when Kubernetes was 0.9. Like there was not even the, you know, the networking component. The Flanner was just getting introduced. So we realized that applications are going to be the important component to integrate with. When I talk about applications, I'm not talking about this client server, you know, you have this virtual machine running front end of the application, and then there is database, right? Maybe 3-tier application. That's not the case. And that is not how we envisioned the world will be. The world will be with applications with a lot more distributed components. microservices were not even born at the time.
Sure.
People started talking about it. That's where the application component. So application to infrastructure management, and the next is basically an automation component. Anything to do with automation is automation. So just back to that circling back, Michael, it's about applications and then automation behind the scene, everything else in between. So that's why Apranix is a name.
All right. Okay, that makes sense. I mean, things around here change so fast. You were saying, before Kubernetes, before microservices. When you were saying that, I was thinking OpenStack back when, geez, what was it? I don't know, 2014, when OpenStack was the rage, and it was the OpenStack Summit was kind of the KubeCon of the day.
Yeah.
Do you see any demand for does your solution work in a pure OpenStack environment as well, or is it just cloud native and Kubernetes based?
It's so we can work on basic infrastructure as a service, and then Kubernetes on top of that, then the application, right? So we look at the entire spectrum. Going back to OpenStack days, I talked about Eucalyptus.
Right.
Eucalyptus pretty much created, in a sense, OpenStack because Eucalyptus had the different licensing aspect, right? And that's how OpenStack was born. So with our multi-cloud management at the time, we supported OpenStack. But the issue has always been, where do you get this hardware stack, right? In order to run OpenStack, you need the hardware. And that is when you look at the public cloud infrastructure, you get the entire stack, right? It's a hyper-converged, infinitely scalable, hyper-converged infrastructure. And OpenStack created the market in terms of putting that software definition for your server infrastructure, network infrastructure, and the storage infrastructure. That's what OpenStack brought in. So our solution, pretty much works on all the public cloud infrastructures. And given OpenShift works on all of these three as a services, we work with every one of them. And VMware is another component, right? So if OpenShift works on VMware, we work on VMware plus OpenShift, and we look everything from that application down the infrastructure. We take care of that.
Okay. Well, how are things going? We're certainly, normally it'd be like, okay, you're 4 years into it. What's your exit strategy? Are you going to IPO? How are you doing? But I'm talking about now, the way, I'm sitting here in my house wearing clothing that normally I wouldn't be wearing. You're presumably, in your house in Holliston. How has the last 8 months had an impact on how you folks are seeing the need for what you're offering? Is it, are you seeing a drastic decrease in sales? Has it changed the way sales are happening? Has it changed the way and the types of solutions that customers need, given that we're probably going to be in this work mode for quite some time?
To be frank, Michael, it has been at the positive side for us. For a lot of folks, it has been a tremendous kind of a pressure financially as well as otherwise. I think this pandemic has created or opened the eyes of a lot of enterprises to see this. It's all becoming cloud first. So when we talk about cloud application resilience, it has started resonating more this year compared to last year. So we pretty much doubled our number of customers, doubled our revenue this year, and we have closed multi-million-dollar deals this year. And Gartner has recognized as a cool vendor in this space. And we certified our product on the marketplace, on the Red Hat marketplace. And it has been a good year for us overall, and we are lucky to be in this position. So it has been a positive one for us, and hopefully for others in this space, hopefully they also reflect the same feeling. But I cannot talk about other folks that are dealing with the data center infrastructure.
Sure. Yeah, thanks for reminding me. I forgot to put in a gratuitous plug for my team here. We've been working with you folks. So my team at Red Hat, we work with software partners to help them test and certify their software as a Red Hat certified container. When you're talking about containers and customer production use of containerized applications, you want to make sure that the components inside that container are fully supportable. So, people can go out and build a container using, upstream community Linux or two Freds in a shed Linux, but if that container breaks, they get to keep both pieces. So, we work, my team specifically works with software vendors to, take and assure that the components inside that container are, Red Hat Enterprise Linux, components plus their software tested together, certified. And then, so whenever there's a CVE that comes out, the customers who are using those containers know that, that the defect repair will happen and the changes will make it back into the upstream, community, so they won't be left holding the bag. And then I think you guys also have an operator, right?
We do. So we are making it easier and easier to use our solution. So we have an operator that is certified by Red Hat, and it is right away available from the catalog. So if you go to OpenShift, you can search through the catalog and you'll get the operator. You can get started from there.
And that operator helps the customers manage their environment in a cloud native distributed environment. So almost like configuration management and AI for the apps themselves, right?
Yeah, so it's basically in terms of introducing our technology, right? It is application resilience that matters. So when you think about an application namespace or multiple namespaces that make up an application environment, there are so many moving parts to these applications, right? Anytime when you deploy a new container or the pods automatically vacate from a node to another node, your application connectivity keeps changing. Now, when you think about holistically protecting that environment, I'm talking about, I am obviously comparing with the regular backup and recovery type of scenarios and contrasting that with application resilience, right? So when you talk about application resilience, that is a higher order compared to the infrastructure level talk, which is about, hey, how do I back up that node? How do I back up this particular VM that is running a set of pods, that is running a set of containers? So when you think about that, it's a different approach, but the problems are same, except that we look at the entire environment, entire namespace, and also we look at from the entire OpenShift perspective. So that's the difference. And from that point on, we talk about any SREs that are managing application-specific infrastructure, combining multiple microservices running on OpenShift platforms. And not only that, but also looking at when the OpenShift platform itself, because it relies on the underlying infrastructure, right? If that underlying infrastructure runs into problem, then entire OpenShift cluster runs into problem, right? So we approach that way as opposed to regular backup and recovery.
And then you said that the operator is available for OpenShift 4 and is in the Red Hat Marketplace. The Red Hat Marketplace is a B2B web store, if you will, that we launched, I think back it was in May of this year. So you folks have a commercial offering of your software. It's as an operator, it's in the catalog, so people can go there and click to buy.
Absolutely. So we worked with Red Hat Marketplace team from the beginning. I think when they approached, we had the catalog operator already certified at the catalog level, so you can go to OpenShift platform, can search for the catalog available. But from a commercial aspect perspective, we waited until the Red Hat Marketplace became GA. So as soon as we were one of the core vendors, when we looked at the OpenShift Marketplace at the time, like only 4-5 vendors. Now it's like hundreds and hundreds, right? We worked with the team to launch it certified, go through all the legal aspects of it. So all of that background information, it's all taken care of by Red Hat. So what customers can directly go is that go through the marketplace, search for application resilience, or even you can search for backup and recovery, locate Apranix, and then go ahead and buy it directly. All the commercial aspects will be handled by Red Hat. So, from an SRE perspective, for them, it's straightforward, right?
Sure.
Directly from the OpenShift marketplace, commercial aspects are already handled. All the pricing, all of that is very straightforward. It's per node. We don't complicate any of that. And billing comes through as part of the marketplace, so you don't have to worry about Apranix getting built. None of that, right? It's very, very straightforward.
Okay. So I was looking on your website. I always like to study people's information and kind of see how they represent their company. And when you go right to the front of Apranix.com, and I'm going to take a quote here from your website. Resiliency with a simple. Let me try that again. I didn't really do so well in English class. Resiliency with a simple integrated cloud-native protection, recovery, cross-region DR, and self-healing service. Now, that sounds to me like a whole lot of buzzword bingo. What is that? What is that in layman's terms? What is resiliency with simple integrated cloud-native protection, recovery across regions with DR? What is that?
So we took a kind of a dictionary type of approach for this. Right? When we introduce a new subject, you have a definition for a term. So cloud application resilience. I think resilience and IT resilience, it's about getting your applications back and running as quickly as possible after a downtime, any type of downtime for that matter. Now, what's the best way to get back into business after some kind of a downtime happens? You obviously look for backup tools or recovery tools, and worst case scenario, you look for DR aspects. So from our point of view, when you look for bringing back your environment, meaning providing that resilience from any downtime, what we do is that you can recover any container or any resource from your cluster at any point in time in any region of the cloud, right? So when you have that kind of a powerful capability in a service, so it's provided as a service, so you don't have to look at how to run this service from an infrastructure perspective or managing OpenShift cluster and applications underneath. You don't have to worry about any of that. All you have to worry about is, can I bring back my application, the rest of the infrastructure, even though it is complicated, moving, dynamic, all of that? Can I bring back any of that infrastructure, resources at any point in time in any region of the cloud? That is so powerful, right? And that is the message that we convey.
So I'm going to date myself here. When one of my first jobs in the IT field was, I used to work for Digital Equipment Corporation, and I worked out in Marlboro there, which you're familiar with. It was MRO2C.
After HP was gone, we were acquired. One of my companies were acquired at the time. We ended up in the same location. It's like brick building. There's a helipad over there.
That I remember trying to get on the off ramp in the mornings, and it was just backed up out onto the highway. But so anyways, I worked with some my job at the time was working with software companies to help them get their apps ported to OpenVMS, Digital Unix, and Alpha NT, if you remember that.
Oh yeah.
And I remember that there were some really big mainstream backup vendors. I mean, backup is not new. Backup has been around longer than us.
Yes.
So why do we need Apranix? I mean, why, backup and data, disaster recovery has been a core piece of enterprise computing for as long as the word enterprise computing has been around. So what's different now? Why can't people just use, those other very traditionally embedded, backup solutions that have been around forever and people really understand well?
Absolutely. So when you think about backup has been there forever, compute has been there forever, storage has been there forever, network has improved. But the difference is that applications are different. So when you think about applications that used to run on mainframe, backup was there to protect the infrastructure for those applications. Client server came in, PC-based revolution came in, the internet came in, right? Web 2.0 companies came in, and then cloud was born to give the enterprises any infrastructure at any point in time, infinitely scalable type of one. So suddenly what has happened is that the application infrastructures have changed. The applications have become a lot more distributed and a lot more dynamic. And if you think about OpenShift, what OpenShift is doing underneath is that it's automatically provisioning the infrastructure for your applications using kube spec. So you send in, hey, I need more storage at this spec level, right? And what it is doing is that it is eliminating bunch of support tickets, and you kind of clarify the support ticket. Oh, what is the size of the VM that you need? Oh, in order to get this VM, I need to have the infrastructure in the backend. Oh, I need 100 gig storage for my node. Oh, I need to go to the storage administrator and get the storage. All of that has changed when you go to the cloud. So you can say, oh, I am going to take my backup system that used to work for mainframe and physical servers and the VMware environment, right? And then say, oh, I'm going to use the same. That's a fundamental thing, right? When you go to the cloud, you don't talk about VMs anymore. You don't talk about storage anymore. You don't talk about networking. You don't talk about load balancer. You simply use an API and or even define in your spec, kube spec, what you want to use. The infrastructure automatically gets provisioned. Now you think about it, when you have to do the backup in that infrastructure, you cannot obviously use the legacy approaches. Your service, because you don't want to even deal with infrastructure anymore, right? You want to deal at the application level, and then the rest in terms of protection and recovery should be automatically taken care of, just like your Kubernetes, right? You don't ask Kubernetes, oh, can you please figure out where that next node comes from, right? Application and SREs, introducing a term SRE, site reliability engineer, that really focus on microservice or application specific reliability, right? They don't say, oh, I need to have X size of the VM provisioned for my pod. That's not the case anymore. So we are asking, why should backup be that way? And when you bring in backup, DR used to be a separate product altogether. In order to do DR, I should be able to take the entire application infrastructure and bring it up in some other data center. That is not the case anymore. It's like my application is running now. The expectation for these applications is like when I am running on Amazon.com, Amazon Web Services,
right?
I expect the reliability to be like Amazon.com. Right? Am I not running on AWS? Okay, so I'm running on Google Cloud. Okay, Gmail is running all the time, right? Outlook.com is running all the time. So my expectation when I go to the cloud is that my applications should continue to run. Nobody talks about, oh, my application downtime is X. And SREs struggle. Look at the moving parts within Kubernetes environment. Too many. And then now, if you put in, can you put in more SREs because there is more moving parts? It's impossible to do. So if you relied on the legacy backup and recovery, you'll be let down at some point in time. You can kind of work through it, but you will have to do so many kind of gymnastics, if you will, to figure out the moving part. With Apranix, you don't do any of that because your system, your application environment is protected. You go and mess around your firewalls, right? Security groups between the nodes. You go and configure your gateways. You go and configure your load balancer, or your config maps within your OpenShift is changing all the time. So how do you keep track of these configurations along with your data, right? And that's where we come in. You don't have to worry about your changing configuration in your production environment. Just take it as somebody is monitoring all of, somebody is backing up, like over a period of time, like a time machine, application environment time machine is captured along with your data, along with your containers. So at any point in time, you can recover them.
And is Apranix, is that software as a service, or is it deployed on site, or how does that work?
It is software as a service. It runs on one of the cloud platforms with all the compliance and SOC, all of that. And we provide enterprise level multi-factor authenticated sign through SSOs, all of the good things that a typical enterprise look for. And you don't really worry whether as a service goes down or not. It's a funny thing that a partner came in on the other day, and he had a backup software that he's using for protecting some of his client. The first thing that the partner did, because this backup software runs on the cloud, right? Runs on one of the cloud platforms. He used Apranix to protect the backup software, right? If the backup software as an application runs on the cloud, that application could go down anytime, right? So he used Apranix to provide the resiliency for the backup software itself. Can you imagine that? It's kind of, that's a situation.
Good creative thinking. So is there, if you have hundreds or thousands of nodes and pods and, applications distributed across multiple clouds, because, OpenShift allows developers to build it once, deploy everywhere. So,
right.
Being the sort of the layer of abstraction between all the clouds, hybrid applications, containers, cloud infrastructure, what is that? What can you talk about hybrid applications? I mean, people talk about hybrid cloud, multi-cloud, on-premise, but what's a hybrid application?
Fantastic question. So if you think about applications moving to the cloud platform, right? They move to the cloud platform, shutting down their data center. That has only accelerated during this COVID time. When you go to the cloud, you are taking your application front-end components, your microservices, right? So you are splitting out in terms of service protocols, making sure that individual services talk to each other with a clear spec. Now you are making those applications much more distributed so that Kubernetes and OpenShift can very easily scale horizontally, right? Making it easier for applications to run. Now, your front-end components are great in terms of containerization because you embed all your dependency libraries, nice packaging mechanism called containers, and you run them on OpenShift using Red Hat Linux, right? Perfect. Now, the back end of that application inevitably relies on data infrastructure, right? The data infrastructure is also changing. It is not like, a client-server application relying on Oracle database anymore, right? And every microservice has its own data infrastructure. You could be using MongoDB. You could be using Cassandra for something. You could be using a very simple file-based database, right? Or you could be using Cloud RDS, relation database services, because databases need their own maintenance schedules and upgrades and all of that. And a lot of these enterprises are offloading that work, right? After moving to the cloud, to the cloud platform providers, right? So you have Cloud SQL, you have RDSs, you have Aurora, you have serverless databases, Aurora serverless, right? You have Redshift, you have unlimited possibilities for the data infrastructure, right? And then you end up consuming other services. So when you have an application defined as the front-end application, very dynamic, running on OpenShift, then you have the data infrastructure running on, RDSs of the world or serverless databases. Suddenly you have something called a hybrid application, right? An application dynamic enough and allowing the DevOps pipeline to change and deploy the changes or the feature requests really, really fast at the container level. And then you have the data infrastructure in the back end, going slower, a different pipeline, different DevOps pipeline, right? Changing differently. Now, if you think about that environment, is what we call it as a hybrid application. Now, when you think about backup and recovery for the entire environment, what do you do? There are too many moving parts, and not a single SRE can really comprehend the entire infrastructure, right?
Think about when you say SRE. I mean, I love acronyms just as much as the next person, but for everyone, why don't you share with us what an SRE is?
Oh, yeah. Thank you for asking that. So site reliability engineering as a concept, as a new way of managing the application infrastructures, right? So when you go to, in the data center, you saw operations, the system managers, system operators, and so on, right? And then cloud operations came in. Cloud operations, is about taking care of the VPC, virtual private cloud, taking care of the networking infrastructure and all of that. And slowly the world has moved to application-specific infrastructure, call it as a microservices infrastructure, and a particular site reliability engineering person will take care of that application-specific infrastructure, providing reliability for that application infrastructure. This concept overall came in because Google started kind of pointing out, how they ran their infrastructure, their Google infrastructure in the backend, right, for applications. And industry has caught on, particularly, along with, Kubernetes, that idea has caught on more and more. But when it comes to backup and recovery, we highlight site reliability because we are covering the entire environment, but that is useful for backup administrators or disaster recovery administrators and so on.
Okay. So I think you said you've got a demo. We've been kind of talking all around this, and I think it would be a good idea to let's just take a look and see what it is you're talking about. So.
Absolutely. So let me share my screen here. When I share everything.
Should be I wish there was some standardization on this video conferencing technology. Everyone seems to put their share button in a different place and call it something else. And
tell me about it. We standardize on Google Meet, and then you come in Zoom, and there's a different button, different controls, and
there was. I was on a conference the other day. There was another one. I guess Microsoft has one, and it had to install all this stuff, ahead of time. And
tell me about it.
Anywho, so let's take a look and see what you've got here.
Absolutely, Michael. So I'm going to just introduce the concept. I know we talked certain aspect of cloud application resilience, how old backup and recovery systems are not sufficient. And then given the time frame, I looked at the possibility of demoing live. I typically do that during the webinar. For this particular situation, I have recorded one of the effective application, container application webinars. So I will cut through that at the end of this presentation. So if you look at what we're talking about, and you take an OpenShift environment. Now, people go to OpenShift or overall container-based applications, and they are going to grow multifold. And all these namespaces and various application environments, the potential possibilities are, fast application delivery. That's a no-brainer, not a problem. And better infrastructure utilization. When you can pack so many containers on a single virtual machine, that's perfect. The utilization always kind of changes. The virtualization era promised the utilization of hardware better, but in the end, it achieved a lot. It simplified a lot, but at the end of the day, from an application perspective, the control wasn't completely given to the application developers. So, OpenShift and the underlying Kubernetes environment promises that along with containers. And they are all running, as I mentioned, on the cloud infrastructure. I'm putting 2 of the infrastructure. I didn't have time, space for adding more. But if you think about it, that infrastructure, believe it or not, runs on a lot of the services that are actually, honestly, taken for granted nowadays, right? People take it for granted that I can create an instance. I can create a volume at any point in time. And there is a whole lot of virtual private cloud infrastructure that a team within enterprise puts together. And then you have load balancers, you have auto scaling enabled behind the load balancer, believe it or not. That has to grow. And then when you put OpenShift has to scale that machine level scaling for the nodes so that your pods can be vacated at any point in time and move over as a bunch to another node because that particular node is running out of infrastructure. So that is the complexity of it.
Can I ask you a question about if you can go back one for a second?
Absolutely, yeah.
Specific to the cloud data stores, and you folks are as a service, if customers are running any one of the cloud native databases that are out there, Gigabyte, NuoDB, Crunchy, Cockroach, do those vendors need to do anything to their applications in order to be managed and backed up by Apranix?
No. So what we do is that we directly go to the cloud account, if you will, right? We ask for a few permissions from our service perspective. It's very standard in terms of the discovery. And we have been certified by the cloud providers, Google as well as AWS, from a security perspective. It's very, very standard permissions level, service account level permissions. Once you give us those permissions, we simply go and discover all the infrastructure. I will show you in a moment how the entire thing kind of gets discovered. So if you're running a newer DB, it's running obviously on a bunch of instances, bunch of VBS volumes. I'm just picking one cloud infrastructure, right? And we simply connect the dots. We know all the, you can create something called a cloud assembly, an assembly of those infrastructure for your newer DB, right? Or Cassandra. And you could say, and cloud assembly, and that cloud assembly, an assembly of cloud resources, in simple terms, gets connected with your OpenShift application in the front end as an external service, right? And that's how we discover it.
Okay. Sorry to interrupt.
Great question. Great question. Absolutely. So when you think about that kind of a complex application environment, think about the downtime situation, right? It's on an average. Again, Gartner puts its numbers. Gartner has always been a very conservative firm. When you think about your application tier, it could be your platinum application that's taking care of millions and millions of dollars of revenue, right? Or any of these tiers, not many times you really think about the SLA and underneath what's supposed to be the recovery times that you are allowed to do, right? Not many cloud operations or SREs can actually think in terms of that SLA and then reducing the downtime. Reducing downtime means, you will have to think about what all the bigger problems that introduce the downtime in the cloud environment. It could be as simple as a bad pipeline, DevOps pipeline coming in and then changing it. You cannot be watching over every one of the changes that's coming into your environment. Or it could be cloud misconfiguration. Oh, somebody changed the firewall. And when was that? Was it like an hour ago or 15 minutes ago or yesterday? Everything seemed to work last week. I went on vacation thinking that everything was fine and dandy. And then I come back now, the application is down. I have no idea what really happened. And then when you operate, particularly on the public cloud, I noticed that OpenShift released as a service on AWS. I saw the news yesterday. So think about that. Most of the complexity of managing that Kubernetes environment, OpenShift environment is taken over by Red Hat as a service. That's perfect. But it is operating on a shared public cloud infrastructure, meaning that you have noisy neighbor problem, right? On the side, it could be some kind of Bitcoin-based, mining going on. God only knows, right? Nobody knows what's happening on the public cloud infrastructure. So, it's in the same network, same rack, and you are going to be affected by the noisy neighbors. So overall, if you think about it, right, your downtime could cost anywhere between, depending on the tier of the application, anywhere between 140 to 300 to 500K per hour. That's a big problem. And if you relied on the traditional backup and recovery, right, and those recoveries do not offer recovery for network, load balancers, firewalls, right? Even if you brought back your application nodes, they don't talk to each other. So how would your application come up? And on top of that, they introduce this lock-in mechanism. They are capturing the data, right? In the data center, that is okay, because there's so many storage vendors, you pull the data, and then you keep it in a backup environment, secondary storage, if you will. But when you go to the cloud, you are running on the same storage engine, EBS or persistent disk or blob storage. And why suck the data out and put it in another data store and slow down the entire process when your application is done? It doesn't make any sense. So on top of that, you don't really understand the dependency mapping between the components, because like you mentioned, why can't we use client-server era created backup and recovery tools in the cloud native world? I mean, when the infrastructures change, there was no Kubernetes, there was no OpenShift at the time, right? And now there's OpenShift with the changing infrastructure. There's no point in using similar architecture, or just because I protected virtual machine, now I can protect containers. That doesn't mean anything, because containers alone, they are not living in their own isolated world. Containers are connected all the time to the pods, the config maps, the secret that you have to maintain. And I'm not even talking about the certificate nightmare that you have to manage, right? All of that won't come in easy. And then when you try to recover that infrastructure, if I go and recover one after another, even if I group them together, 100 virtual machines, 100 nodes come up together, I don't know the configuration. How fast can I recover from the environment? You need to use infrastructure as code. Who writes those infrastructure as code? That's too complex. That's why Gartner is saying, even if you started with some kind of a backup, right? It's better to look at your entire application environment, look at from an application resiliency perspective, right? And things will become a lot more clearer. And yes, you have to do backup. Yes, you have to do disaster recovery. These are all like, yes, it's a table stakes, right? Nobody, at some point, people will start talking about backup, right? Backup is a chore. I have to do it. Let somebody else do it. Some service take care of that. Let me worry about application resilience, right? So that's the aspect that we talk about. And when you think about Apranix, forget about all of that, infrastructure level talk, nomenclature. You don't talk about VMs, you don't talk about nodes. You talk about how do I protect that application environment, right? Virtual machines, containers, combination of those. That's what we call as a hybrid applications, containers plus infrastructure, OpenShift running your container world, and the rest of the infrastructure. So we look at, when we discover that infrastructure, we discover everything within that application environment, the connectivity between the components of that environment, right? And when you recover, you can click and recover this particular resource or the entire environment at any point in time. This is what I call it as an application environment time machine. So, I want to recover in the same region where I protected, just like a backup recovery. Or I want to go to another region where I have to think about multiple zones. Every zone is a data set, huge data set, right? And when you think about spreading out that Kubernetes, even the OpenShift infrastructure spreading out between 3 different zones, when the cluster goes down, your entire application environment is down, right? So how would you bring up that entire OpenShift environment in another region of the cloud? What are the connectivity pieces around it? You will have to take care of that, right? So that's what application resilience is all about. When you think about doing that, guess what? We released it in such a way that it's a SaaS, meaning per 1 and 2 are one-time activities. You subscribe, go to the marketplace, OpenShift marketplace, or any of the cloud provided marketplaces, and give permission to discover. It's read-only. And then you simply add your policies. I want to protect every hour. I want to protect every 15 minutes. I want to protect, every week, retain it for 4 weeks or 5 weeks, depending on a month. And then protect every month, retain it for 12 months. Protect every year, retain for 5 years. All of the traditional kind of a policy-oriented mechanisms, you simply key in policies, Apranix takes care of it, creating that application environment and machine. Then you simply go and pick up that, right? And having done that, now you can graduate to a level where you talk about continuous resilience, right? Now that you have achieved that backup and recovery based, take care of Apranix, worry about my dynamic, ever-changing application environment, protect it, please. Once you're done with that, you graduate to the pipeline-oriented approach. So you already have CI/CD established with your tools. Go ahead and use any CI/CD pipeline tools and structure. There are so many of them, right? OpenShift comes with a packaged approach as well. So you could use built-in OpenShift CI/CD a tool set. And what you could build with Apranix is continuous resilience. So continuous integration, continuous deployment, or delivery. Along with that, you could introduce continuous resilience with a single line of code integrated into your pipeline. That will take care of protecting your environments. So at any point in time, you can roll back, even if you had a bad deployment, you could recover it or completely fail over to another region, right? All of that will be taken care of. So from a demo perspective, I cooked up this on top of GCP because we have credits, we use GCP. You could do exactly that on AWS or Azure, not a problem. For demo purposes, again, it's just a demo purposes. We have a Kubernetes-based application running microservices here, and you have the data infrastructure running Cloud SQL. Like I mentioned, it's a hybrid application. And then you have some MongoDBs and things like that running in one of the regions of the cloud with a cloud load balancer connecting. The applications is running. The data is copied to the other region. So synchronous or asynchronous copy, totally fine. Make sure that it's copied. Now, if the entire thing comes down or resources come down, you could bring it back again, right? Apranix, with the touch of a button, will bring back the entire application environment and switch if the Cloud SQL is involved or RDS or any of the data infrastructure components involved, switches it back, brings back that application. So that's the capability that we have in terms of creating an application resilience and providing that application resilience when you operate your applications on OpenShift plus the data infrastructure in the backend, right? With that, now if you look beyond the legacy approaches, mainframes, perfect infrastructure for that time. Client server, great. Virtualization-based VMware environment, perfect. They all satisfied to a level. When you go to the cloud, it's different. A lot more dynamic. When you think about 10 VM-based environment, now we are talking about 80 different resources, right? So, when you go to the OpenShift level, then you have a lot more config. If you look at the config maps, it's very complicated, right? And a lot of moving parts, and the many pipelines are introducing changes to that infrastructure, right? When you think about that, you don't not only think about just a region 1, you can now have one region 2 with multiple zones, or you can even have additional protection in another service account completely. Right? Think about that level of resiliency. That is unheard of in the data center days, and unheard of even in the cloud days, and unless you know how to make use of all these wonderful capabilities, right? And that's what it is in terms of application resilience. So you can get started very easily. But before that, let me also give you that entire demo. So I recorded the demo. If you think about it, this is the application that, it's a very well-known distributed application. Thanks to VWorks, they open sourced it. You can go and buy socks all day long, tone socks, if you will, right? And that application needs to run continuously. So if you look at the shopping cart here, there are 267 items running, and we spin off an automated population of that socks shopping cart. So we automate using a test script. It keeps filling up that shopping cart item. So to simulate that, your e-commerce application runs continuously, and in the back end, that application looks very, very dynamic. If you look at the complexity of the application, it runs on the data infrastructure with the dual node, but that application has so many moving components. If you look at the dynamism of that application is pretty complex, right? It keeps changing. If you look at the processes, that's the type of application that you see on the application environment perspective. But if it comes down to protecting that environment, as I mentioned, Sock Shop is that application name. You have the backend infrastructure. It runs on the instances that cloud platform provides, and you have the load balancers, you have the Cloud SQL, which takes care of the backend data infrastructure, and on top of that, you have the container resilience. So if you look at Apranix, you have container resilience that provides the resilience for your OpenShift-based applications, dynamic applications, and the external assembly consisting of your data infrastructure is protected using the cloud resilience. So both of them will be protected using Apranix. This is what I call as a hybrid application. And in that hybrid application, if you think about it, at any point in time in the timeline, we call it as an application environment timeline, Apranix automatically captures that timeline, and you can go and say, recover my entire cluster, recover the entire cluster on the East Coast. This application runs on the central region, and we recover on the East Coast, and then get the external service at that particular point in time. So if you're going back to last week, you will have to identify what was my OpenShift configuration config maps from that particular point in time, 12 o'clock at the last week at that particular point in time day as well, and identify the point in time database copy, right? And bring back that infrastructure at a particular point in time. So when you think about it, it's very complex and so many moving parts, so many different configurations, right? And operations folks do not have time. Even if you put the operators together on the OpenShift, you will have to deal with a bunch of operators, right? With Apranix, single operator connected to our service takes care of all the complexities for you. So when an application is down, all of the backend, if you think about it, Kubernetes engine in the backend automatically brings back. Then from a recovery perspective, it comes back in about 2 to 3 minutes, and it writes all the infrastructure as code. So if you think about it, ton of infrastructure. This is a very simple application. It has about less than 1,000 lines of infrastructure as code that is automatically written and brought back up as a single unit so that entire thing comes back completely on the recovery side. So all your applications will come up within the deployment area, and Cloud SQL will be automatically shifted back, and your application will come back. And your cards, if you look at the engine in the backend, it will come back as well. So,
hey, Govind,
yep.
You were talking about the importance of time in your demo right there. I do want to point out that we have just a little under 2 minutes left.
Got it. I was rushing through this demo part, Michael. Thank you for pointing.
Sure.
We have only 2 minutes. So, the point that we want to convey is that you are putting together, as a customer of OpenShift, a complex and dynamic application infrastructure, right? Consisting of many containers, consisting of many namespaces, maybe spread out across many different clusters, right? I have seen hundreds and hundreds of clusters in an enterprise environments, right? It's not just one cluster alone anymore. And when you run that kind of a complex application, that is one level of complexity. You'll have to worry about the skill set for your SREs or operations folks. And second of all, think about the application complexity going down into the data infrastructure, right? Given all that complexity, think about your application resilience, right? When you think about application resilience, think about, can I recover any of my containers at any point in time, any of my cloud resources at any point in time, in any region? And how fast can I recover really defines the capability for your teams to recover from the downtime. And then downtime really costs a lot of money, depending on your application types. So, that's the difference that Apranix brings in. Again, to go back to that naming, Michael, that Apranix means applications to start with, right? And we look from the application down to the infrastructure, and how we can provide application resilience is all we talk about, breathe and die on, right? Yes, backup is necessary. We take care of that. Yes, disaster recovery is necessary. We take care of that, right? And all you have to worry about is applications. Is my application resilient or not? So let me stop here and see if there are any other questions from you, Michael. It has been a wonderful experience talking to you.
I don't have any other questions. I know that I kept interrupting you here and there, but it was pretty interesting talk track. So we are running out of time here. So I just want to put up our call to action slide here. Please stop by the Red Hat Marketplace. You can check out the Apranix certified operators there for OpenShift 4 in the marketplace. Govind Rangasamy, CEO of Apranix, thanks for coming today. I'm really glad that you were able to be part of our show here on the OpenShift container briefings. And I'm Mike Waite from Red Hat, and we're wrapping up another show this week. So thanks for coming, everyone.
It's a pleasure. Thank you, everyone.
Recording has stopped.
Well, I think that went really well. How do you feel, Govind?
I think it was fantastic. I think you streamlined it much beyond my expectations. So really, really appreciate it.
Well, normally what we do is we get a half-an-hour call a week or two in advance, and I just kind of ran out of time. And I was talking with Cyrus this morning, and I was like, "Do we have his front and back slides? Do we have the talk track?" And I was like, we better get that stuff going here." So, anyways, yeah, thank you, and we will get the recording off to you. We're going to take your